Here we are on part 2 of aquatic and terrestrial pollution. We're going to start with impacts on wetlands and mangroves. We've been talking about all these human impacts on ecosystems, and one of the ecosystems we really want to talk about is our wetlands and mangroves. So wetlands are ecosystems where water is covering the soil either all or part of the time. Plants are adapted to being partially submerged, and mangroves are very similar in that their roots are submerged, but they're trees that live on the coastal intertidal zone. So they're kind of adapted, no, not kind of, they are adapted to more brackish waters. And both of these ecosystems have so many ecosystem services, habitat for so many organisms, so much biodiversity. Wetlands are extremely important for migrating bird habitat, right? They nest, they brood, they mate. Very, very important to so many organisms. Both mangroves and wetlands offer flood protection. So wetlands really absorb so much water, and so they really protect the surrounding areas from that excess water. Mangroves also, and also important in mangroves is that they're protecting from storm surge. When you have like a hurricane or something and the surge comes in, mangroves are really protecting against that. They filter water, they purify the water. So, I could go on and on and on, but I'll keep going to, for the sake of the PowerPoint. Okay, so they're being threatened by pollution, which we've been talking about, and overfishing, dam construction, so, right, that alters the flow of water for our wetlands, and that can be really harmful. Additionally, right, remember that sediment doesn't come through, and then, right, your nutrients are much lower when you have a dam upstream. That sediment doesn't come down. And then also just commercial development. Most places have a no net loss policy, that where basically if there's a wetland, you cannot build there unless there are plans for a constructed wetland, which is what this picture is, the top left picture. They don't function as well as a natural wetland as you could imagine. And also they're not really super well regulated by the EPA, so it's not a very good replacement. But even in the city of Stamford, they have a no net loss policy. So if there's a wetland, you got to stop. But basically, commercial development is really affecting these ecosystems. So another issue that we want to talk about is eutrophication. Eutrophication is the addition of nutrients into the system or into the surface waters. Cultural eutrophication is the anthropogenic inputs of these nutrients. And so the major macronutrients that we're most concerned with is nitrates and phosphates. And these are coming from surface water or groundwater discharge into surface waters from fertilizers. So agricultural fertilizers are running off through surface runoff into our surface waters, or they're infiltrating into the groundwater, which then discharges into surface waters. Sewage discharge, animal waste. Let's say there's a concentrated animal feedlot and that animal waste is not dealt with appropriately, or there's a breach in the containment pond that enters the waterways, you end up with excess nutrients. And then erosion, because as we know, nutrients can absorb onto sediment, and when there's erosion and excess sedimentation into waterways, that can increase our nutrients as well. And excess nutrients can actually cause an algal bloom. So they're a major plant nutrient, macronutrient, and so the algae grows like crazy and then ends up kind of forming that blanket like you saw in the last slide. And what lives also dies. And so once that algae dies, and also the animals that are coming in and eating the algae, right, their waste increases and all of that falls to the bottom. Then the bacteria that are decaying that material are using oxygen, and so it creates this hypoxic zone or low oxygen zone in the water. And as we know, organisms need oxygen, and they either avoid them or die, right? Move, adapt, or die. So it's too fast to adapt, so either organisms move out of the way or die. And so one of the most infamous ones that we should know about is in the Gulf of Mexico. It is the size of Connecticut. It's massive. And so it forms every summer because of agricultural practices at the time of year, just excess nutrients coming from the Mississippi. And so, in the fall and the winter when nutrient use isn't as high, you end up with less nutrients in the system, so it kind of mixes and goes away. But basically, the Mississippi dumps into the Gulf of Mexico, and voila, you have this like massive dead zone. And the reason why it stays there for a long time is because that fresh water discharging from the Mississippi is less dense, so it's just floating on top of the salt water and it's just not mixing. And so, yeah, that's not good. Another issue that we see is thermal pollution. We talked about it before, right? Because of industry. So in nuclear power plants, we talked about it, but really in any industry and power plants where they're using water as a coolant, those discharges into surface waters are increasing the temperature of that water, and it reduces the ability to hold oxygen. So again, right? Move, adapt, or die. Okay. So another pollutant that we definitely need to talk about is persistent organic pollutants, or POPs as we call them. And so persistent organic pollutants are synthetic carbon-based molecules, and they're persistent. They don't break down easily. And so what happens is that they accumulate in the fat tissue. And the problem with that is they cause cancer, reproductive issues, neurological issues, suppress immune function. And so they get stored in that fat tissue and then just slowly kind of release into the body and has all kinds of effects, like I said. Because they're persistent in the system in general, they're easily transported by wind and water. They don't break down, so wherever the water and wind go, so do our persistent organic pollutants. Here are some examples I think that you should know of. DDT, which we've talked about before, PCBs, BPAs, a lot of stuff in plastics and fertilizers and pesticides. And so Stockholm Convention is trying to prevent the use and production of these persistent organic pollutants. And so a lot of the world has agreed to this, the US not being one of them, one of the countries. And all of these pollutants that we've been talking about are magnified in the food chain through bioaccumulation and biomagnification. So bioaccumulation is when the chemical is accumulating in the tissues, and biomagnification is as it goes up the trophic levels, it magnifies in concentration. And finally, I threw this in here. It's not in the topics, but I think it's important to note water laws because you need to know them especially the Safe Drinking Water Act is one that you absolutely need to know. The other one that you absolutely need to know is the Clean Water Act. I threw some others in there because they're interesting. But right, the Safe Drinking Water Act of 1974 are consistent standards for safe drinking water across the country. Why does that matter? I mean, I like clean water. I don't know about you. Of course, you have issues like Flint, Michigan, where you have lead contamination in your drinking water. And so the people in charge weren't testing it appropriately and they weren't taking the proper measures. And look what happened. You have these people who are just affected by lead in their water, and they have all sorts of issues, neurological issues. There are kids that are just never going to develop properly because of that. And the Safe Drinking Water Act is something that should have protected them against that. And so, when you take shortcuts, bad things happen. And it just goes to show that, laws are very important when it comes to human health and the environment. Other things, like we talked about, litter and plastic pollution. And so there's the Ocean Dumping Ban Act. The problem with that is that, like, who owns the ocean? And it's so big. How do you even regulate that? And then the Oil Spill Prevention and Liability Act. So basically, it helps the EPA respond to those oil spills. And I just kind of threw those last two in there because we talked about littering and dumping, we talked about oil spills, and those are laws that have to do with that. And so finally, we have the Clean Water Act, and the Clean Water Act is really important in setting standards for key water pollutants, so not just in your drinking water, but also, just in surface waters and such. And so it just like the Clean Air Act controls emissions, the Clean Water Act also controls emissions on point sources. So you have a certain limit that you're allowed to discharge into waters for certain industry and wastewater treatment.